Hi there, my name is Pete Goddard and I'm the CEO of Deephaven Data Labs. It's a real pleasure to be here at ODSC West and have this opportunity to talk to all of you and introduce you to the open source projects that Deephaven has made available and is continuing to evolve in the service of data scientists, AI and ML engineers, particularly at the intersection of your workload and real-time data. At the core of today's conversation is going to be three open source projects. The first is a query engine that's particularly unique in addressing real-time and historical data or static data together. The second is an API that allows for communication between Deephaven servers or servers and clients. And the third is an open source project that we develop and we use heavily for data visualization, for tables that can tick or that can handle huge data sets, and for dashboarding. The first of these three projects is the Deephaven Query Engine. It's really unique. It came from Wall Street. It's where Wall Street's been driven by real-time data for 30 years. The second project that I mentioned is called Barrage. It is that extension of the Apache Arrow Flight. It is built to make communicating about dynamic data very, very straightforward. And Deephaven uses it both in server-to-server communications as well as talking to remote clients, whether they be the JavaScript ones, the web UI you'll see in a moment, or others. And then the web UI itself really is quite fully functional. It's designed to handle huge data and dense data and to update in real time, to be fairly interactive, to be a nice consumable both for exploration and data interrogation, but also, to build proper apps, whether they be widgets you embed in other things or full dashboards you create for yourself or for others. At the center of all of, or at least the first two, I would say, but certainly intersecting with the third project as well, is the concept of streaming tables. You guys certainly know what tables are. Data frames are heavily used in R and Pandas, and one could say Excel tables or not Excel, SQL tables are pretty darn similar in many ways, at least for OLAP functions. And event streams are well known. So Deephaven really just smashes these two concepts together and creates a sibling that's somewhere in the middle. So one can use the power and intuition and frankly libraries that exist on tables, but those tables can change over time. Streaming tables are really nice because it allows for less data to move over the wire, and by keeping track, instead of just micro batching the whole table, the Deephaven query engine and the Deephaven APIs really address just table changes, the table deltas. So the appends certainly yes, but also the modifications and the deletions and the shifts in the table in very efficient ways, which really opens up some use cases for you. So let's hop right into a demo. The first thing we want to do is go to a terminal and launch Jupyter Notebooks, or Notebook the way all of you typically would. Sure enough, here it's launching, good. And I have a notebook canned with a demo to walk through. So the first thing we're going to do is we're going to pip install Deephaven. You can install Deephaven in a variety of ways, either via this pip method or using our Docker images. You can build locally. We have lots of Docker images as well with pre-canned libraries like, I want to launch it with TensorFlow already in or something like that. I'm going to start the server. In doing so, really the only configuration is what port do you want the web UI to hang off of. Okay, so we want to work with some data. The first thing we're going to do is just work through some random data, sort of like the first time you used pandas. Let's create some fake tables. In this case, it'll be fake tables that tick in real time, but let's manipulate them in fairly straightforward ways. So one simple way to do that is to create a timetable. So we're going to import a timetable from Deephaven, and then we're going to create a new row every second. Sure enough, it looks like that ran. I can't see it. And this is a dynamic table, so typical widgets that would be available in Jupyter won't do much for us because we want them to tick in real time. So in this case, we're going to use that import from earlier, that IPy widget, and we're going to access something called Deephaven widgets to render tables. So we're just going to take that table, T, and then we're going to display it. Okay. In this case, I set some formatting as well. So now you can see that a new row is coming in every second, and that that in that I have, both the timestamp and just the row number, right? And you can see that this is truly dynamic data, and this is a classic Deephaven table widget. Okay, this is a pretty dull piece of fake data, so let's just add some more columns to work with, then we can look at some basic table operations. So I'm just going to add some random columns, of integers and doubles and things of this nature. So there we go. We have a slightly more interesting table where now new rows are coming in, but they also have some more pertinent data decorated on them. Okay, and then in the next couple of minutes, just working with this fake data, I just want to go through some basic operations so you understand sort of the scope of what Deephaven can do. I want to project some new columns. I want to do some calculations. I do that by really just setting up a directed acyclic graph of logic, right? In this case, I have the table T that I defined up above here, right, that I first defined here with this timetable. I added columns to it, and now I'm going to manipulate it in more ways. I'm just going to say, oh, I want to create other columns that are very simple combinations of various logic that exists from the columns that are already present in the table T. And then I'm going to do some formatting, and I'm going to change the size of the display here. So now you see, sure enough, we have both the original columns or data set that was here, and now we also have these manipulated or derived data coming in, just based on, is it mod 10? What is it mod 10? Is it even or odd? The random numbers that are there, different things that are straightforward. And I've demonstrated that you can also impose both conditional formatting based, on a Boolean, as well as heat maps, based on ranges that you're seeing and things of this nature. So now we want to show a very important concept of Deephaven. There's really only two that matter. The first is everything's a table, even if it's updating in real time, and I think this table right here is exemplary of that. And then the second is that with Deephaven, you just write one bit of logic after the other, maybe simple logic or maybe very sophisticated logic, but you can write it in. It supports quite linear thinking, right? There's no query optimizer or anything like that you're wrestling with. So I have a table T, and I'm going to, in the graph now, take that table and do something simple with it. In this case, I'm just going to do an aggregation, a last by, based on some key, or based on a couple of keys. And I'm going to name that work product something else. So this is called T_last, which when I run this now, you'll see that we have both the original table continuing to update, as well as this derived dependent table, that this acyclic, that the graph, the logical graph, is suggesting table changes in this derived dependent product inherited from this, source table, so to speak, right? And aggregations are very straightforward. The syntax for a lot of these things should feel like pandas meet SQL, written in fairly straightforward fashion. Let's hop through a few of those quickly to save time, right? Instead of just doing an aggregation, I want to take the original table, and now I'm just going to filter it for some condition. In this case, I've just said, where this is true. You'll see that if I filter on this and I look for false, sure enough, nothing shows up because, I've imposed this filter. And again, all of these tables will continue to update in real time, which is kind of nice for pandas that we're supporting state and all of this, these real-time capabilities, not just server side, but also rendering them through the UI in these table widgets. Instead of doing one aggregation, let's say I want to do several aggregations at once. So I want to do some counts, some sums, some averages, and then I want to join, do a natural join or something very similar to a left join, with these data sets. And now I have some sort of summary view. And you can see that, again, the the pink row is only visible about 3/4 of the time because I started with the filtered view. And then finally with this fake data, we want to just take the source table T, and we're going to split it into even and odds, and then we're going to bin the data by 20 seconds, and then join join that data in between the even and the odd. So you can see, okay, we're starting with the even table here. We have the odd table here, binned by 20 seconds each, and then we're just taking for each of those keys. In this case, I mean, it's a time-based key, but for each of those keys, we're joining in the even and the odd data. So again, showing binning and joining in combination with some of these, the filtering and aggregations. So I've returned to the Jupyter Notebook homepage because we don't want to just work with fake data. We want to work through some real examples here. So I've opened up another notebook, and here we go. We're going to, again, install. We're starting fresh, so we're going to install and then deploy the Deephaven server locally here. And then we're going to do something interesting. We're going to establish a new place to write down dynamic data. So incoming data essentially can be written to Deephaven in a number of ways, but the most generic way is to use something called a dynamic table writer, whereby you define a table based on data types, and then you will write those data types to a table of a particular name that you create. And then in this case, I've cast that name to another one because we're going to put Twitter tweets into it, so I'm calling it a tweet table. So now this table exists. There's nothing in it right now, but it does exist. So then all I've done here in the next cell is I've used the Twitter API to go look for, to listen to tweets in real time based on keywords. So those keywords that I've chosen are based on these. So these are from, it's the World Series right now, and Amazon had bad earnings a couple of days ago. So it seemed like interesting things to track. So now I'm listening to those tweets in real time, and they're being put into this table that I've named called tweet table here, right? And if we want to see those, just as previously, we can just use that IPython widget, the Deephaven widget, to display those results, right? And now we should see, sure enough, this is a real world example of us listening to tweets in real time based on the Twitter API. And of course, as seen from the earlier table operations, if I said, oh, I want to do, an aggregation that just simply says, hey, is this a retweet or not? And then I want to watch those counts in real time. Sure enough, I can do that really just based on a string search as to whether this is a retweet or not. A very simple example, but it's really quite powerful to say, oh, I can use the Twitter API in combination with Deephaven, and really the sky's the limit now in regards to what I want to do. Now, for sure, I've shown only the most basic use case here of a simple aggregation, but bear with me, and we'll move on to another example to show where this can go. Before we move on to that other example, though, I just want to show you another place that you can see this data, and sort of as a transition to the other one. So here I'm looking at this data and ticking in real time in these table widgets in Jupyter, but I could go up to port 10,000, and that means that I can go to localhost 10,000, and we'll see a Deephaven IDE here, right? An interactive experience that we're going to show you in a moment, but even though I was creating that in Jupyter, we can see all of the tables that are available here, right? So here's that retweet table, that aggregation in real time. Here's the raw tweet table that we were talking about before with all of its, interactive experiences that, oh, I only want to see stuff from this keyword or that one. So it looks like this is all stuff related to news. So even though you're working in Jupyter, you can also see that all of that data here in the Deephaven IDE naturally. But I'm going to use port 10,000 again, so I'm going to get rid of this here. I'm going to go back, and as before, I'm going to turn off my Twitter feed, and then we're going to launch Deephaven in a different way. Hi, I'm now in a terminal. I'm going to go to a folder that has a notebook that I want to use. There we go. And then I'm going to launch Deephaven using Docker. Okay. If you go to our website, you'll see that in the community products get started, there's all sorts of quick start instructions, not only the pip install I showed before, but also launching with Docker images or building from source. So that's launched. So now I can go to localhost 10,000 and here we are. And again, it has a notebook that I wanted to access that is open here. We want to work with some real data. So crypto data from Coinbase presents an opportunity. Just to show you what you could do is you could hook up to a Kafka feed, for example, and simply configure where the Kafka feed comes from and how you want to receive it within Deephaven. And that would be a wonderful way to get real-time data. But instead, we're going to go and we're going to use the WebSocket client, and we're going to connect to we're going to connect the Coinbase. Oh, come on, baby. There we go. We're going to connect the Coinbase to get data via their WebSocket. So now we've launched a WebSocket connection, and then we're going to write the data that we receive using that method we talked about before called dynamic table writer, which just says, hey, using this schema as new data comes in, I want to write those JSON loads into the table that I happen to call Coinbase WebSocket table. So sure enough, now you can see that that's coming in. And, this is a table that's growing. So if I spin it on its head, you'll see that sure enough, that's ticking in real time. So kind of interesting. And, obviously there's all sorts of things you can do, to these tables interactively, as I've hinted at before. But again, this is an AI conference, so we're not going to go through too much pointing and clicking. Let's say I want to take this table and do a basic summary where I aggregate by instrument and size, and then I, present some other statistics. That's very straightforward to do. So again, now here we've got, all of that data coming in. It's ticking in real time as it aggregates as to how many trades have there been and what notional. And I want to go back. I'm not too interested only in Bitcoin, so I'm going to instead open it up to some more crypto pairs, and you'll see that even just by changing something upstream, now that WebSocket data will just flow through the graph to that table we called basic summary. So because this table is continuing to update now for more things than just Bitcoin, so I could say that, I want to not see the Bitcoin, I want to see the other stuff. You can see that other things are coming in, and sure enough, all that is hitting the table I called basic summary as well. So let's do some other basic things. Again, we'll get to complexities in a second, but I wanted to show you what it's like to do some time series joins. So here I've separated just the Bitcoin data on the left and just the Ethereum data on the right, and I want to take the original timestamps from the table and then join in Bitcoin and Ethereum based on time. So do a binary search based on time and then calculate the ratios in real time. So now, where is that table? There we go. So now I have this table that are, for every timestamp of the original table, it notes the last Bitcoin and Ethereum trade price. And then I can use that, and based on whatever keys I determine, I can do an EMA calculation, right? So here we are. I'm calculating EMAs based on 5 minutes. You can do EMAs very easily for whatever grouped key data you want, either based on time or on ticks if you'd like. And then it's very straightforward to plot the data. I could plot it via the UI, but instead I'm plotting it here programmatically, right? And I don't know, this is a little bit ugly, so let's just take off the Bitcoin and the Ethereum and only be left with the EMA. Oh, sure enough, it's pretty noisy. Obviously, these are very, very small numbers, these changes. But, there you go. That's the raw ratio price and the EMA. So now I want to go beyond simple table operations, and I want to show you something a little that feeds your imagination a little bit more. In this case, I want to take that table we've been working with, okay, that one, that had the EMAs of Bitcoin, Ethereum ratio, and I want to introduce a new computation that uses a custom bespoke function that I define, as well as a third-party library, right? In this case, scikit-learn. So all I'm doing is creating a new function of my own that calculates the beta between Bitcoin and something else. In this case, it'll be Ethereum. And to do that, it uses a linear regression model imported from scikit-learn. Right? Now, I don't expect this to be thrilling results because it's Bitcoin and Ethereum here ticking around just over these few seconds or few minutes that I'm discussing it. So I expect very, very low correlations, but I can import that model, and then I can run this analysis, and we'll see, sure enough, that analysis is ticking in real time. It's a number pretty darn close to zero just because, whatever, they're randomly ticking back and forth more or less on the bid and ask in not very correlated fashion. So I wouldn't expect high numbers here, but you are seeing that calculation is using a custom function and a third-party library with table calculations at the same time. The last thing I want to do in this demo before we run out of time is show you that actually Deephaven not only can support simple directed acyclic graphs and more complex directed acyclic graphs like this one that was calculating the EMA we suggested, but also you can get data from remote Deephaven workers in support of your application and your AI. So really you can have microservices of data-oriented applications, analytics, AI models that are all working together. So the way one does that is via an integration, something we call a URI integration, right? So you can, for both raw data sources as well as for applications, in this case, this is an application scope, you can subscribe to a variety of things. In this case, I'm going to subscribe to a table called trade streams that another Deephaven application is publishing. Right? So this is not a raw source. This is not WebSockets. This is not the Twitter API. This is really just a Deephaven table that's being provided by another application. You can see that it's sort of flashing around. Sometimes it's one size, sometimes it's something quite a bit smaller or quite a bit bigger. That's because we have a very smart way of getting in data, supporting its consumption, but not adding to memory, right? So I can take this derived data source from somewhere else, for example, and if I wanted to, I could do something simple where I'm just counting the rows of data. So as soon as I started that aggregation, that's just going to say, oh, what have I inherited locally? And that's just counting the rows as it adds up, right? But if we want to see something more complex, I could inherit a different set of data from that application. In this case, I'm looking at, exchange and instrument totals really for a couple of months here. You can see that, this is, if I go here, let's round this out. You can see that we're talking about, I don't know, what is that, 50 trillion dollars of Bitcoin versus, that's not straight Bitcoin, but these stable coins here trading against Bitcoin here since we started this aggregation, let's say several months ago. So I can subscribe to that, and then just as suggested in that picture, right, I not only can subscribe to the data, but I can do things to it. So I'm going to, for example, join the local calculations that I was doing a few minutes ago with this data that's been sourced from the remote worker. And now, sure enough, I have not only the basic summary that I've been calculating locally, but then I can join the two in where I say, let's take the summary from the remote application and let's join it with the basic summary locally, and now we have a result. So there you go. I hope that you find that all of this is powerful infrastructure for working with real-time data, for using your Python user-defined functions, for using your third-party libraries really to do whatever you want. And all of it is available out there today just by Googling GitHub Deephaven, and you'll find many of our projects listed here, but in particular Deephaven Core, our API, and our Web UI client is what I've been showing you today. Thanks so much for your time, and I look forward to your questions.